So welcome distinction scholars. So in this video, we're talking about the question that can come under transverse waves. So if you missed the video talking about the introduction to wave motion, the types of waves like transverse and longitudinal wave, make sure that you watch it, okay? So let's talk about the question that can come under what? Transverse wave, okay? So they're saying start the wave diagram below. So start the wave diagram below. As you can, this is a wave diagram like that, okay? This is a wave diagram and it has this, okay? Now they're going to ask you the first question, okay? They're going to ask you the first question. Basically, they're going to say, okay, define a transverse wave. Define a transverse wave. So that could be a first question. So what do you know about the transverse wave? So what is a transverse wave? So a transverse wave, we know that this is the type of a wave where what? The direction of a vibrating particle, they are forming a 90. Basically, that direction is perpendicular to the what? Movement or the direction of the wave. So what are we saying? So in simpler terms, we are saying that this one is what? Type of a wave. So we are saying type of a wave where the direction of a vibrating particle is what? Is perpendicular to the direction of the wave. So that is the simplest definition that you can give, direction of what? Of a wave. Okay? So that's the first one, okay? That's the first good definition of a transverse wave. So basically, the transverse wave is what? It starts the type of a wave where vibrations or the direction of the vibrating particle, they are perpendicular to the what? To the direction of the wave. So that's basically the transverse wave definition. So now, what could be the second question that they can ask you? They are going to tell you, state two examples of what? State two examples. Okay, state two examples of what? A transverse wave. So let's just say T wave, okay, a transverse wave. Take two examples of a transverse wave. What could be that? Two examples of transverse wave, it can be what? What did we say? We said the first answer is water waves, okay? Water waves, what else? Electromagnetic what? Waves, okay? Electromagnetic what? Waves. So let's just put initials, electromagnetic waves. So remember electromagnetic waves, what did we say? A good example are what? Radio waves, ultraviolet waves, there's X-rays, gamma rays, all those examples are what? Electromagnetic waves, and they're under what? Transverse wave. Okay, so let's go now to another question. Roman numeral 2 or 3. So what can they ask now? So now they are going to ask you to identify what? X. Okay, identify X. So what is this X? So X, as you can see, it is showing starting from here up to there. What did we call that? We call it what? We called it what? Amplitude. So that is amplitude. Remember the definition of amplitude. Amplitude is just the displacement between the what? Equilibrium and up to the highest point of the what? Crest, or up to the lowest point of the what? Trough. That's what we said. And amplitude is measured in what? Meters. Okay, since that is the length or displacement, it's going to be measured in meters. Okay. Now, what other question? So they are going to ask you another question. They are going to ask you another question. So they are saying from the diagram, show the wavelength, okay, and label it as what? And label it. Let's just say and label it, okay? So from the diagram, let's show the wavelength, and we need to what? Label it using what? Its symbol. So we're going to label it using what? Its symbol, okay? So labeling from this diagram, they are saying we need to show them that, okay, this is what we're talking about. This is the wavelength. They are going to get some marks. From the diagram, show the wavelength and what? Label it. So what is the wavelength? From the definition, we said the distance of one wave, or we said the distance between what? Two successive crests and what? A trough. Remember that, what did we call this? What did we call this one? We said what? The crest. As you can see, this is the what? The crest that we called, okay? And this is what? Another what? Crest, okay? So the distance between two. So they are saying now, from this to important point that you know, you need to label it. So you need to say, okay, from this highest point up to that highest point, then you do like that, you draw a line like that, then you need to label it as what? A wavelength like that. You need to put the symbol for what? Wavelength like that, okay? Then you are going to get marks if you do that, okay? So now, under Roman numeral 3, they are going also to ask you this. Let's put A now. Okay, calculate what? The wavelength. Calculate the wavelength. Yes, calculate the what? Wavelength. So that's where a problem now, where the problem can come about. Okay, so calculate the wavelength. Since we know now how to state the wavelength, okay, remember that the wavelength is the distance of one wave, and it is measured in what? Meters. Now calculate the wavelength. So how can you calculate the wavelength? Remember, the moment they ask you to calculate the wavelength, what are you supposed to do? Write the formula for what? Wavelength. What is the formula of wavelength? Okay, although even if this one I said, okay, you can use it, but it can somehow disturb you, or maybe make a question to become difficult, but just go back to this one, which is so simple. Okay, so what is the formula for the wavelength? The formula for the wavelength, we said, so wavelength is nothing but equal to what? Distance over what? The number of what? Waves. Very important point. Okay, wavelength is equal to distance over what? Number of waves. So now what you need to do is, before you do anything, since from this question you're saying calculate the wavelength, write the formula for wavelength. Then what's the next step? Next step, you need to put data here. So put data. Okay, put data. So what have you been asked? So you need to find the distance. Okay, you need to find the what? The n and the wavelength. Okay, wavelength, quite alright, is the question that you've been what? Asked. Okay, so you put the question mark there. Then what about the distance? So this distance, this small letter d, you go to the what? To the wave diagram there. The distance that you are going to be given for the whole number of waves that you have, then that is the d, the small letter d. Okay, so this distance that we are looking for here, this is 30 meters. So starting from here up to there, that is the distance of all these waves that are here. So it's a d that we are talking about. So what are we saying? D is the what? It's the distance that has been given from the what? From the wave diagram. Okay, what about n? And now we need to count how many waves are there that are covering this 30 meter distance. Okay, so what are you going to do? So what you're going to do is what? You're going to count. Remember how to count? So you need to make what? AC. Okay, so this is the first one. So starting from here like that, you make S like that, then up to there, that is what? One wave. Up to here, this is one wave. Okay, so starting from here, then you count like one. Again, you go next. Starting from here, we make S like that. This is what? 2. Okay? Then that's where we end from. Then from here, then you count again like that. That is what? 3. So how many waves are there? There are what? 3 waves. Okay? And remember that if I was to add another one here, okay, I just add like that, okay? Another one. So here initially at this point is what? 3 waves. Then I've added this one. This one is not making S. This is just C. N, like it's a big N like that. So that one, this is 3, then this is half. So we are going to say, if I was to end here, we are going to say this is 3.5 watt waves. Okay, if I was to add this one, okay, then we are going to say 3.5 watt waves. This is a 0.5. If it's not making a complete S, it's a 0.5. Okay, then 3 plus 0.5, you are going to get what? 3.5. Okay, or 3.5 waves. Okay, but basically our question is just ending from what? 3 waves. Okay, then you can continue. Now what are you supposed to do now? Where there is D, now you start replacing it for you to find the wavelength. So where there is D, you put it, the thing that you have there, that is what? We have 30. Okay, where there is D, you put what is 30 meters. Then N, how many waves do we have? We have what? 3. That is the 3. Then if you divide 3 into 30, you're going to have what? 10 what? Meters. Then that will be our correct answer. Very important what to take note of. Okay, so since now we've understood that, now let's put another question that is talking about frequency and what? talking about it on how you can calculate frequency and period. Okay. Then B, then they are going to ask you to find what? Frequency. So B, then they ask you, okay, if the time taken, so they are going to give you this condition, time taken for the wave diagram above, is maybe, let's say, okay, let's say maybe 60. They are saying 60 seconds, okay, 60 seconds. Then they ask you Roman numeral 1, then they say calculate. The first one is what? They ask you to calculate the what? Period. Okay, we'll start with period, then end with what? Frequency. Again, so because there are a lot of formulas that we are going to be using from physics, so now how best can you choose that this is the right formula that I'm going to use? How? Because you need to go to the what? To the question. The question is talking about what? Period. Now from the formulas that you know, which one contains period, then you go back. Which one contains period, you come back here. So which one is this one? As you can see, this is period, then equals the time taken over number of oscillation. You write it so that you know what to do. Okay. So the question is talking about finding what? Period. What are you going to say? What are you going to do? We're going to write what? T is nothing but equal to time taken over what? Number of what? Oscillation. Period is nothing but equal to, what are you going to put? Time. Remember, if you put data here, what is the time taken here? For the all wave speed, we are saying the time taken is what? 60 seconds. Then what about N? N remains the same. N, we are talking about the number of what? Waves. How many waves did you count? We counted what? About 3. So a number of waves doesn't have what? Units. Don't make a mistake like that, okay? So I'm going to put now, start replacing what is T. We're going to put what? 60 seconds over what? N is what? 3. What could be the answer? 3 into 60, it will give us what? 10. Then what's the correct unit for period? What did we say here? If you look at here, the period is measured in what? Seconds. So you put what? Second. That's the correct answer. Very, very simple and straightforward, okay? Then what is the other question that they can ask you? They are going to ask you to find what? Frequency. Okay, now frequency is going to have what? 2 formulas, okay? Frequency is going to have 2 formulas. Let's start with the simplest one. The one that I gave you here, okay? Frequency is what? So we are going to say frequency is nothing but equal to, we said, number of oscillation over what? Time taken. This is what we said, okay? Then you say frequency is nothing but equal to number of oscillation. How many oscillations do we have? We're going to have how many? We're going to say there are 3 over how many number of oscillation? We know that the N is what? 3. And what about the other one? The other one is what? 60 what? Second, which is time. Time is 60 seconds. Then you solve this one, okay? We know that one will be 1 over what? 20. Okay? 1 over 20 is, if you want, yeah, well, simply just saying 3 there is just 1. 3 into 60 is just what? 20, like that, okay? 3 into 60 is just what? 20. Now this one, if you want, you can use a calculator so that you can have decimal numbers like that, okay? But since here, minus wasting time, let's say 1 over 20. If you want, you can put it in what? Decimal numbers. Then you put what? The correct unit as Hz or second to the power -1. Then what else? What else? What is the other formula that you can use? Apart from this one, there's also another formula that you can use. Okay? Apart from this one, we know that frequency is somewhat related with what? Period. We are going to say frequency is equals to what? 1 over what? Period. Okay? 1 over what? Period. 1 over period. So now frequency, you are going to say frequency is nothing but equal to 1 over, then ask yourself, what is the period that we solved? Okay? The period that we solved is what? The period that we solved is 3 into 60, we solved, which is what? 10. Okay? 10 what? Seconds. It's a mistake. Okay, so now let's say they ask you the question to find the what? The period. So now how can you find the period? The period basically, that's from this formula, which is T. Okay, we know that it will be what? t equals to what? Small letter t over what? N, according to that. Now the question that you can ask is that how can you know that this is the formula that I need to what to use? Then the only thing that you can do is that you ask yourself, okay, I've been asked to find the period. So period, then ask yourself, which formula among the formulas that I know, which formula contains like period? As you can see, the only formula that we said that is going to have period is what? This one. It is the period is nothing but equal to time taken over what? Number of what? Oscillation, which is very, very simple, okay? Now, if you know something like that, well, then what else are you supposed to do? Now, you put data, okay? We know that here, we know that t is what? 60 seconds, because the time taken for the what? O wavelength. How many waves are taking 60 seconds? They're about what? 3. If you come here, you count, there are 3. This is 1, 2, then 3. There are how many waves? There are what? 3 waves. Okay. Then what is left is what? To find the what? Just the period. Time taken is what? 60 seconds over what? Over what? The number of oscillation are what? That is what? How many number of waves? There are what? 3 waves. Then if you look at that one, if you enter 3 into 60, it will give us what? 20. Okay, 20 what? Second. So that would be what? The correct answer. So that would be what? 20 seconds. So this is the simplest what? Question that you can encounter. Then what is the other question that you can be asked? The other question that you can be asked is to find what? Frequency. To find what? Frequency. So how can you find frequency? Again, how can you know that, okay, this is the correct formula that I'm going to use? Ask yourself, which formula contains frequency? Then you are going to say, okay, the only formula that I had that contained frequency was what? This one. Frequency equals to what? Number of oscillation over what? Time taken. But there are 2 ways in which you can find frequency here, because you already have period. So now let's talk about the frequency. So how can you find frequency? We know that frequency is nothing but equal to, okay, it's number of oscillation. Don't make any mistakes. Number of oscillation should be on top there as a numerator over what? Time taken. Then frequency is nothing but equal to what? Number of oscillation. How many waves are there? They are about what? 3. Over what? Time taken is what? What is the time taken? 60 what? Second. What will be now the frequency? Since we don't have a calculator here, we're going to just reduce 3 there. It is 1. 3 into 60 is what? 20. Okay. Then we're going to put what? 20 seconds. Basically, if you now, this is the frequency, this is the final answer. If you divide this one, basically, the final answer is going to have what? 1 over 20. What's the correct unit? Hertz. Or you can put second to the power -1. Remember that frequency is measured either in hertz or second to the power -1. So the other unit that you can put is what? Is second to the power -1. But basically, just put hertz. Okay. I'm not saying you put hertz and second to the power -1 at the same time. No, just choose one. Okay, but the most comfortable one is just hertz. Okay. Now, what is the other way around that you can solve such a question? You can solve it. This one. There's also another one. Frequency is nothing but equal to what? 1 over what? Period. So there is this relationship between period and what? Frequency. As you can see, period and frequency are what? Inversely proportional to one another. Basically, if you increase the time taken or if you increase the period, you're going to decrease the frequency. If you increase the frequency, you're going to decrease the what? The period. So they are inversely proportional to one another. Inversely proportionality states that if one component increases, the other component is going to what? Decrease. Okay, so now let us talk about that. Let's see if it's going to give us 1 over 20. So this formula also what it works. It can only work if you have what? Period. If you've solved what? Period, it can also work. But also this one, it can work, but it's going to give you the same answer. So what are we saying here? Frequency is nothing but equal to 1 over what? What's the period that we solved? So you come here. This is the period that we solved. It is what? 20. You're going to say we solved the 20 second. If you divide this one, you're going to have what? A decimal number if you want. Okay. Here we're just going to remain there. Okay. So we're going to have a decimal number. So I'm going to just say 1 over what? 20. What's the final units for frequency? Okay. So as you can see, either this formula or this formula is going to work for what? For frequency. Okay. So let's add the last one. The last question. Let's add the last question. Yes, let us add the last question. What is the last question now? So let's talk about the wave what is speed. So wave speed. So what is the wave speed? So Question C. Calculate. Now you can calculate the wave speed. So calculate the wave speed. So this is the last question that you can be asked. So what is the wave speed? So wave speed, basically they're talking about the speed of the wave, which is measured in what, meters per second. But basically remember that speed and wave, these are what, speed and velocity, these are the what, like similar type of quantities, because they are going to contain what, same units. But the only difference is that velocity is what, vector quantity, which has what, both direction and what, magnitude. If you talk about speed is what, a scalar quantity, because it's only going to have what, magnitude or size, but no direction. Okay, so basically regardless of that, what is the formula for wave speed? So remember that the moment you've been asked about what, a question from physics, basically you need to understand, to say, okay, that question needs what, needs a formula. So you need to get used with what formula, different formulas when it comes to physics. Okay, so what is that's the formula for wave speed? So the formula for wave speed is what? So the speed of the wave, so we say V stands for speed of the wave, or velocity of the wave. That's the same thing. Equals to what? So we say we get frequency, then you multiply with what? Lambda. Remember that lambda is what? Lambda is what? Is wavelength. Okay, well, lambda is wavelength. So you multiply these two, then you are going to get what? Velocity, or the speed of the wave. So we are going to say this is nothing but equal to, now, frequency. Do we have frequency? Yes, we have frequency. It is what? We solved it, which is 1 over 20 watt hertz. So you say 1 over 20 watt hertz. But if you want to make it simpler, you convert this 1 over 20 into what? Decimal numbers. Basically, by using a calculator, you type there 1 divided by what? 20. It's going to give you a decimal number. Then you simply multiply with what? What are we multiplying? We are multiplying with what? Wavelength. Now remember that what was our wavelength that we solved? You come back here. So what is the wavelength that we solved here? As you can see, this is the wavelength that we solved. It was what? 10 meters. Okay. What was the answer for the wavelength? It was what? 10 meters. Then the velocity will be what? If you multiply these two, basically you are going to have 10 there, it is 1. 10 there, it is what? So 10 there is 1. 10 there is what? 2. Okay. So you are going to basically have, if you multiply everything, 1 times 1, you're going to have 1 over 2 times nothing there, it will be just what? 2. Basically, the answer here, 1 over 2, we're going to have what? 0.51. What is the correct unit for the speed? Speed is what? Meters per what? Second. Meters per second. So that's where the final answer is. So basically, that is the simplest thing that you can take note of. Okay. Now that's where we end from, and remember that make sure that you subscribe and like the video. Okay, so in the next video we'll talk about what the other type of waves, like the longitudinal. We'll talk about the sound waves, the compression, the rarefaction, the use of sound wave, the limitation of sound waves, all those things. We'll talk about it. Stay tuned, make sure that you study hard. All the best.